Discovery, go at throttle up.
Okay, what's going on, everybody? We have the Artemis 2 Wet Dress Rehearsal News Conference happening. Well, it should be happening in about 3 minutes. Let's see how it is. If you guys didn't catch the extended space news that we did yesterday, you're here for about 8 hours watching the Wet Dress Rehearsal. And yeah, unfortunately, the Wet Dress Rehearsal for SLS last night did not end well. They did get all the way to terminal count, which is really good. That's a really huge step. But they, per the mission timeline, they went to pressurize the core stage hydrogen tank for flight and encountered a leak rate on the core stage hydrogen tail service mast umbilical. The leak rate exceeded the ability for the recirculation system to handle it. Yeah, not great. So we're gonna watch this press conference here, and surely it will go fine. Surely there won't be any hostility from the press. Surely. Didn't they have a hydrogen at H2 leak on the tail service mast last time too? Yep. Oh, and here we go. On time. Let's go. Audio is notoriously underdriven. Give me some time to balance this out. Alright, hold on. A little bit overdriven.
the challenges overcome, all the teamwork that has brought us to this point. I'm very, very grateful and proud of the team for doing that. I know the administrator shares that. The wet dress rehearsal we had last night was a critical milestone on the way to Artemis 2. That was the reason we went to the pad, was to do this test. It allowed our teams to test all the systems required in the all-up configuration. I think it's clear based on what we saw in real time, we're now targeting no earlier than a March for Artemis 2 launch. The Artemis 2 astronauts have been released from quarantine this morning. They remain in Houston. I want to extend my deepest gratitude to every team member who worked tirelessly on the wet dress rehearsal and all the critical steps that brought us to this point. Really, I mean, it was an incredible effort from so many people to get to this point. Their dedication, expertise, and perseverance has paved the way for us to enter a new launch window. Every challenge that all of you overcame and every detail you perfected led us here, and this milestone is a testament to your incredible work. We're going to review all the data as expected. We just got off console. Charlie got off a little bit later than the rest of us, but we'll review the data, address the items we saw during the wet dress that need future work, and we'll set another series of integrated tests as we go forward, and we'll gather everything we need, and we'll update you as soon as we can. I also want to personally extend my gratitude to this team here. We're missing some of the key team members, but they did just an incredible job getting through that test last night. We had challenges throughout, but the way they managed themselves with poise and dignity and got as much data as we could while the vehicle was in the test configuration, really just a phenomenal job. So really, really grateful to them, and I'd like to hand it over to Dr. Glaze to give you the real details.
Great. Thank you so much, Amit. And I'd also like to thank you all, those that are here in the room and those online. Thank you so much. You saw the image of the rocket out of the pad. Those of you that are here have been out there and seen it out there, and I can just say the excitement is just really building. You can feel it in the air when we're out here, when we're near the rocket. It really is spectacular. As Amit said, the wet dress rehearsal is an essential part on our path to flying our 4 crew members, Reed, Victor, Christina, and Jeremy, around the moon and bringing them home. I can tell you that I was conversing with our commander, Reed Wiseman, as we went through wet dress yesterday and following. I know that Amit and the administrator also spoke with the commander, and so we've been staying in constant communication so that they know where we are and that we're all together on this as we are moving forward with our plans. I'd just like to say a couple of words about the wet dress. We really did learn a lot from the Artemis 1 mission, and we implemented a lot of the lessons learned yesterday through wet dress. And I would say many of those were demonstrated very successfully. And then we were able to actually gain additional data as we were going through the rehearsal. Myself, I know when I went in, I had 3 big things that I really wanted to make sure we were getting data on. And I would say all 3 of those, we did a fantastic job of gathering the important data that we need. First off, everyone's aware of some of the challenges with the hydrogen tanking from Artemis 1, and we had made some changes. And I would say the fact that we got to full tanking yesterday on the first try was tremendous success, and we gathered an enormous amount of data on the processes and how we want to go forward with that in the future. So I think that was a huge success for us. Another area that I was really focused on was there's the purge barrier that we do the nitrogen purge. We have done in the past nitrogen purge between the crew module and the LAS, and we tried something new yesterday, and I really wanted to make sure that we gathered data on how that was working. That'll inform how we perform that in the future to keep the crew and the support staff that are in the white room, keeping them safe as we load the crew, and we got a lot of data there. Fantastic. And then the third area that I was really focused on is, closing those doors, closing the hatches on the crew module and the launch abort system is a challenging process. It's very complex, a lot of steps. It's a big deal, and the more times we can practice that, the better. And I think we again got another rep yesterday. Our team's got some more work there. They've learned, and we've again gathered a lot of important information that's going to help us as we're going forward. Of course, we also identified some additional issues, and we will be tackling those. They tackled them last night. The team did an amazing job. I want to thank Charlie for her incredible leadership, but Charlie and her teams and John and all of our teams that were involved with the wet dress yesterday tackled a variety of challenges in real time and did a great job there. As we've done all along, we rely on the data that we collect through these exercises like the wet dress rehearsal, and it's that data that leads us and sets the pace for where we're going. We have another opportunity in front of us to test our tanking operations and countdown. As Amit says, we will do another wet dress rehearsal in the future, and we look forward to that additional opportunity to learn more about our systems before we launch our crew to the moon. So we got a lot more work to do to get ready for that mission, and we are ready. Our teams are ready. Those incredible individuals that Amit noted, they are geared up and ready to take us forward. I'll hand it over to Charlie.
All right. Thanks, Lori. Appreciate it. And thanks to everyone who is here with us today, either in the room or online. So you heard Amit and Lori both talk about our wet dress rehearsal. So we got into our call to stations on Saturday evening and had our plan T0 for yesterday. Got into our go for tanking. We were a little bit behind getting out of the pad, and we got to go for tanking right around 11:30 local time. Got into chill down for both LOX and hydrogen. That went very well. Nothing notable there per the timeline, per the plan. When we got into the LH2 fast fill, which was around 12:29, is when we picked up our first leak in the TSMU in the cavity, which is where the flight and the ground plate come together, and it's that cavity in between. And it's in our 8-inch fill and drain line there. We have a QD that kind of connects those two together. So it was similar, I would say, to some of the signatures that we've seen during Artemis 1. Our leak rate was a little bit higher, somewhere in around the, I would say, 12 to 14%. As you know, we went back, we did some testing between Artemis 1 and Artemis 2 and determined that 16% was an appropriate leak limit for LH2 in that cavity, and so that's what we managed to yesterday. So we saw the leak get up around our limit, and we did a stop flow revert, and when we did that, we saw, of course, the leak came down. We tried a contingency procedure that we used during Artemis 1, which is you let that QD warm up, you let the seal warm up, and you try it again. And so we did that a couple times, worked our way through it, and was able to load the core stage all the way to replenish. LOX load went for both core and upper, went really without any issue at all. And we got both stages to replenish, all stages replenish about 17:44 local time yesterday. We worked through a couple things. We had a targeted T0 originally for after 9 p.m. in the evening, but given the contingency procedures and whatnot, we had a new targeted T0 at just after midnight. And we picked up the count, T-minus 10 minutes. We counted through our got through our polls, picked up the count, counted through 6 minutes. Of course, the crew access arm comes back at 8. That was a big milestone for us. First time we'd ever done that in terminal count with the ground launch sequencer. So a big win on that. It came back just fine, latched into place just like it's supposed to. And we got down inside the 6 minutes, and that is where we began core stage pressurization. And so as we began that pressurization, we did see that the leak within the cavity came up pretty quick. We did a cutoff, which is a normal safing activity for us. We got into our safing steps. We saw the hydrogen concentration come down, and then later in the evening, we got into our drain operations. I am happy to report that early this morning, we had the core stage drain was completed at about 6 o'clock, just after 6 this morning, and right now we have all commodities off the vehicle. Both stages, both commodities are drained. We are in core stage boil off and inerting activities, and we're getting the pad open back up for control work. So that's a little bit of how the test went. Lori talked about some of the great things that came out of the test. I'll tell you, we had never loaded the core stage or the upper stage from the new 1.4 million gallon hydrogen sphere. We had gone through a complete verification and validation, but we didn't have the hardware to do it with, the flight hardware. And so that went really well. The lessons learned from how we do the sequencers in the software also went well yesterday. Already talked about LOX and the CAA. And then the replenish valve, those of you who were around for Artemis 1, remember we had to send a red crew to the pad for the replenish valve, and we made some design modifications on that valve, and it worked flawlessly yesterday. And so that went really good. Lori talked about the breathing air injection that we had for the service module purge, and that was a late mod that we did. Again, worked really well while we had the closeout crew out at the pad, and we were able to do a full closeout of the crew module. So all in all, a very successful day for us on many fronts, and then on a couple of others, we got some work we got to go do. And we're going to go do it. We'll figure it out, and we'll be back here talking to you once again about when we're going to target our next wet dress and the results from that. And with that, I'll hand it over to John.
Thank you, Charlie. Yeah, so this is the first opportunity for us to get the integrated stack for Artemis 2 on the launch pad with all the systems working together, and see it loaded full of the oxidizer and the fuel, and get through the countdown operations. It was a great demonstration for the hardware and for the team relative to performance. To me, the big takeaway was we got a chance for the rocket to talk to us, and it did just that. Test gave us exactly what we needed. It was an opportunity for us to wring out the system as well as the team before we asked our crew to go fly on launch day. I'm always particularly proud about the rigor that our teams put into reviewing the data. They stay hungry all the time, and I've been talking to some of them on the phone this morning about looking at data and what we're looking for, and just sharing some thoughts there. Going to the MMT was in place.
Mission management team.
Ahead of tanking operations, providing guidance to the launch director at our planned checkpoints that included the tanking operations, as well as the go for terminal count. We also provided guidance on a couple other points, which I would say were minor risk acceptance items along the way. And that's, that's the big part of what the MMT does, is provides risk assessment and approves risk or not. And finally, I'll wrap it up by saying I fully support the agency's decision and the plan we've got moving forward. Rachel, back to you.
All right, it's time now for questions. We'll start here in the room, and then we have several already waiting in our question queue on the phone. Another reminder for those on the phone, you can get into the question queue with *1. And with that, let's start over here with Marcia Dunn.
Hello, Marcia Dunn, Associated Press. 3 years seems like a long time, enough time to wring out any hydrogen leak problems. Why wasn't there more aggressive testing checks since Artemis 1? And sorry, I'm just losing my thought here. If you could just explain how you can still be having the same problem 3 years later. Thanks.
Yeah, so in my old job as the course day or the SLS manager, after Artemis 1 and the challenges we had with the leaks, we took a pretty aggressive approach, as Charlie mentioned, to do some component level testing with these valves and the seals, and try to understand their behavior and their tolerance for surface finish and FOD or debris or scratches or something like that, right? And so we got a good handle on that relative to how we install the flight side and the ground side interface there. But on the ground, we're pretty limited as to how much realism we can put into the test. And then at the end of the day, and what I would say to that is, we try to test like we fly, but this interface is a very complex interface, and when you're dealing with hydrogen, it's a small molecule. It's highly energetic, and we like it for that reason. And we do the best we can. And actually, this one caught us off guard, and the initial things that we were seeing, and the technical team felt like we either had some sort of misalignment or some sort of deformation or debris on the seal.
I would just add that to Marcia's point, we did make some changes, while not to the cavity itself that John was explaining, but we did make some changes to several of the hydrogen components. I talked about the replenish valve. We had a leak there. We did a design mod. It worked great. We also made some changes. If you remember from Artemis 1, we also had changes in what I would call the back of the plate, in the purge can and in the debris plate. We changed the flex hose design that comes into the back of that plate. We took the way that some of the hardware was mounted and made it hard welds into the plate. We also took off some of the things that had a cantilevered load. That was some improvements we made during Artemis 1, but we did make overall improvements to the ground side of the plate, and we did not see any hydrogen leaks there yesterday. So those two areas were things that were lessons learned from Artemis 1 that were incorporated, and they tested out really well yesterday. And it was the first chance we got to do that test in this environment.
Okay, we'll go behind Marcia to Bill Harwood.
Thanks very much. Bill Harwood, CBS News, with three very quick but related questions. And I know you can't answer them, but I'm going to ask them anyway. What is the earliest you think you could do another WDR? I know that's an open question. If a rollback is ultimately required for whatever reason, would that rule out the March window? And finally, if the original leak you saw during fast fill, hydrogen fast fill, has showed up on launch day, and you got the tanks filled using your technique, and you never had that problem when you pressurized the tank, would you have been good to go with the original leak, or was that we're out of here no matter what on launch day? Thanks.
Would you answer the last one first? I'll take.
So where would we have been on launch day? If we were able to use our contingency procedures and we had launch window left, and we haven't gone and done the deep dive on all the timelines to see exactly where we would have landed, but certainly if we were within our parameters for launch day, within our allowable 16%, and you had not had the issue when you pressurized during terminal count, you would have been within your launch commit criteria and certainly could have been go for launch.
Yes, I'll take a couple of the other ones there. The first question about the second wet dress rehearsal. We are, a few hours off of completing the wet dress from yesterday. Our teams have a lot of data they need to assess. We need to put together what the plan is and the various tests in addition to wet dress. What else do we want to do between now and then? So there's a variety of things that need to be taken into consideration. So at this time, I don't have a date for when that will be, but we certainly will let you know as soon as it gets scheduled. I'll make sure everybody knows. I don't expect it'll take us too long to get to that point, but we are still in the process of assessing the data that we collected yesterday and developing the plan. We do believe that we do have contingency pad access now available to us, and that it appears at this point that the work that's in front of us can be conducted out at the pad, and that's what we anticipate. I don't know if you wanted to add anything to that, Charlie.
So I would say a couple things, right? During Artemis 1, we found out that we can do some work on these plates at the pad. Now, I had hoped that we did not have to demonstrate that again for Artemis 2, but we showed that we can go do this work at the pad and be ready for launch. And so that's I would say the first order of business this afternoon when we're done here is for the team to start looking at what that would take and how we'd get into that configuration. Of course, as Lori said, we'll let the data drive us in terms of what the work is in that cavity.
This is space.
But we'll start putting that plan together today. So that's the first part is I think, yes, we can do that out at the pad. The other is that we do have contingency pad access. We developed it for a reason, and that was so that we could do our FTS reset for our clock with the range. And so we have that equipment available to us, and we have it laid into our nominal plan should we need to bridge launch periods between 17 and 18.
All right, we'll go here in the front row, and then we'll go to a few on the phone.
Hi, everybody. I'm James, our local reporter at Channel 6.
So given that you're waiting one more month at least until launch, how's the pressure feel amongst yourselves to finally fly the crew, get them around the moon, especially considering the administration wants to land on the moon in just 2 years? Thank you.
Sure. I mean, we feel the pressure to make sure that we're listening to the machine and we're doing the right thing for the crew. I would tell you that we put that pressure on ourselves to be successful, but we don't feel any schedule pressure on this particular subject, specifically for Artemis 2, other than the learnings we're going to get from flying SLS and Orion again. There's not, from the production side, there's not particular components that we're waiting on to process the Artemis 3 hardware. Of course, we're doing major development activities with the lander and the spacesuits, which are, kind of separate from these things, but the Artemis 3 core stage will be delivered to the Cape. At least the top 4 fits will be delivered here in a few months. We put eyes on the seat command and service module at the ONC. They're in TVAC testing right now. They're ready to be joined. All we have to do is append the new heat shield, which we developed and is qualified and ready to go. So that production activity is occurring separate from the launch activity for Artemis 2. However, if we do have learnings from Artemis 2, obviously we'll have to cut that into the design. And so we're just we're just doing our normal business, but cranking out hardware for the subsequent flights as we proceed with this launch.
All right, we'll take a few questions from the phone before coming back here into the room, and we'll start with Jeff Faust with Space News.
Hey, good afternoon. Wondering if you could provide a little bit more details about the hatch issue that you reported during closeout activities on the pad last night. Exactly what was going on, and why is the hatch closure apparently a pretty complicated, involved thing that made it one of the top priorities you wanted to check out in the wet dress? Thanks.
Yeah, so I'll comment on that. So the reason we wanted to check out the hatch during the wet dress is just there is limited opportunity to go do that with the integrated vehicle. And we had an opportunity during CDDT for the first time, but the environment's a little bit different being out at the pad. And yes, it's the same hatch, closes the same way, but there's something unique and different about being out at the pad in a cryogenically fueled environment of the rocket that is underneath. And so we wanted to take that opportunity to have the closeout crew demonstrate that. In terms of the complexity of the hatches, there's 2 of them. First off, there's 2 of them to go close out. Folks that were around from shuttle maybe remember the single hatch and the timelines associated with that. This one's a little bit different because you got to get the crew module hatch closed. You've got to get, Lori mentioned, the purge barrier out, which is it serves as kind of like the name implies, a barrier for that interstitial area, and it's multiple components that come out, and then there's just the closeout of the white room itself. So there's just a timeline and a waterfall of work. I don't know that there's any one thing that is very complex about it. It's just the series of work. And of course, for us, we're always monitoring that work because it does contribute to how long our crew is on their back before we get to T0.
All right, we'll take another one from the phone from Joey Roulette with Reuters.
Hi, thanks. Questions for anyone. I just wanted to re-ask Marcia's question on why this hydrogen leak caught you guys off guard this time. As John Honeycutt said, why wasn't this detected earlier as a possible thing that could come up? And then also I just wanted to get clarity on the Orion closeout work. I know we just talked about the Orion issue, but Jared Isaacman said that additional factors included extended Orion closeout work. And so what is the work ahead on Orion? Thanks.
I'll take the first part. Maybe you guys can do the Orion.
That was
it's a good question. As we said, we test the component level, right? And we made the improvements we made from Artemis 1. I think, and I don't want to get ahead of the data review, but part of I think what might be contributing to it, and we have to go inspect the seal and see if it was, what condition it's in. But, when we're mated to the tail service mast and we roll, that rollout environment is very complicated, as you see the size of the machine there and kind of the way in which we have to push it out to the pad. So, and while we're rolling, that interface is in communication. And so, we don't really know exactly. It's very hard to predict kind of what credit we can take for and what the acceleration environment is all the way up and down the stack. When we did Artemis 1, in fact, we did a lot of stop and start tests to see if we could characterize it. But even then, it's pretty complicated from a stress and strain standpoint. And so that's not an excuse. It's just that's the first configuration in which we've been able to witness that environment. Lots of times when we We look at the duration the rocket can stay at the pad. We have very good understanding of like onshore winds and those loads and how those affect the mated stack, because that's more predictable. The one thing that's very hard for us, and we kind of keep in our pocket as pretty constrained, is the number of rolls. Those of you guys that followed Artemis 1, we were very particular about that because we can't take credit for the witness of that rollout environment. It's very complicated. And so we think that's a contributor, but again, we have to tear the seal apart and see what happened. And I'll leave that for the Orion question for y'all.
In terms of the amount of work, if I'm following the question correctly, the amount of work in Orion closeouts for where we were in wet dress, when we were essentially configured for launch, that was always part of our plan because we wanted to limit the amount of work between WDR and our earliest launch opportunity. So in terms of a lot of work within Orion, there really wasn't a whole lot left between WDR and launch. We did have some late stow and some other things, and obviously the final configuration for launch relative to some of the crew equipment. But overall, we were in I would say, very close to launch configuration yesterday.
Okay, we'll take one more on the phone and then come back to this side of the room. The next question is from Eric Berger with Ars Technica.
Hi, thank you very much for doing this. Earlier today, the NASA administrator said of DSLS, the flight rate is the lowest of any NASA-designed vehicle, and that should be a topic of discussion. And so I'd like to ask about that. Going back to the green run years ago, I think that this is maybe the 7th or 8th time the SLS rocket has been fueled, at least the core stage, and all of these tankings have been pretty adventurous. So I'm just wondering, given the low flight rate, do you think launching this rocket is ever going to be more than an experimental process? Thank you.
I'll take that one, Eric. It's a great question, and I think you're right. The flight rate is not it's long. 3 years. It was brought up by Marcia earlier. That's a long time between the first test and the second all-up test. Of course, we've been testing across the board, in different configurations. This vehicle is designed to, or at least our test campaign is designed to conduct these all-up tests. We do component and other level testing where we do this tank pressure testing when we machine and manufacture the test. So we do get that data, but to be fair, it is going to be experimental because going to the moon in this configuration with the energies we're dealing with, and every time we do it, these are very bespoke components. They're in many cases made by incredible craftsmen, and so the geometries of them, even though they're within tolerances, each one of them is different. Honeycutt said earlier, this is the first time this particular machine has borne witness to cryogens, and how it breathes and how it vents and how it wants to leak is something we have to characterize. And so every time we do it, we're going to have to do that separately. This is the configuration that we need, the energies we need in order to achieve these near-term missions. We've been talking with the administrator, at length about this, and he's very passionate about making sure we achieve the objectives of the campaign using this, but also making sure that as we go forward, we try and get to a higher flight rate so we can get more learning, and that is exactly the approach we need, which is why we're pushing for this test for this February window, and we're going to try to, as Charlie and Lori and the guys get ready to go, get another test as quickly as we can.
Okay, let's go to this side of the room. We'll start here in the front.
I'm Philip Sloss. I think for Charlie, just to try and get a little bit more color on what you saw yesterday with the hydrogen concentrations in the umbilical cavity, because when we first saw it, we first saw the report, you were up to about 55% or somewhere in that neighborhood. Did you see elevated hydrogen concentration throughout fast fill, or did you see a change near the point where you tripped the limit? And then were you seeing any difference between the flows through the fill and drain line and the bleed line, either in that space of time, or again, you talked about getting into pressurization at T-minus 6 minutes. I assume you get into drain back at that point through the bleed line. Is that what possibly tripped the limit during terminal count?
So let me start with when we saw the leaks. Let me start there. So, what we have learned during the Artemis tanking campaign is that this interface is sensitive to flow rates and pressures. We learned that during Artemis 1, and we saw the same thing. Yesterday. It was when we went to fast fill. We were in slow fill. We were within our limits and within our bands. It was when we transitioned to fast fill that we began to see the limits creeping up, or the concentrations within the cavity creeping up. And we did, was it a steady rate? I mean, it increased. We got up to, probably 12, 14%. And then when we got close to the 16%, that's when we did stop flow and revert, and decided to invoke our procedure for letting that interface warm up and then retrying it again. During Artemis 1, we found that sometimes that was very successful. I mean, that's a pressure-assisted seal, so sometimes letting it warm up and then putting some more pressure across it, you'll see the seal improve. And so that was the goal yesterday. When we tried it the second time, the performance was pretty similar. We have the ability, and what we do in that case is that we are actually pressurizing in the storage area, in the sphere itself, and we're kind of using that pressure to, hydrogen's light, and so you put some pressure in the system and kind of push it, as we say, push it up the hill. And so we started out with a lower pressure, but as we put additional pressure and got back closer to our fast fill rates, we started to see the leak. And so it was, I would say, in and around the 12 to, when we got up to 16%, we would take action. We saw that through the 3 different contingencies, but we were able to manage it. We would manage it with the pressure, get back within your leak rate in the cavity or get close to it. And so that's how we managed to get all the way to replenish. In terms of when we saw the spike in the leak, it was in terminal count. It was as we began to pressurize the tank, and whether that came from through the 8-inch or the 4-inch bleed, we really need to get into the plate and take a look, and we'll know more, in a few days when we get in there. So it'd be hard to say at this point. Again, the team's going through the data, so if you ask me tomorrow, I might have a better answer. But right now, I'd tell you that based on the timing, it looked like in real time that it was likely through the 8-inch. Could have been the 4 though. So we'll take a look at all that and see what was going on there. But it did go up, and it went up very quickly, and so we knew that we had something there we didn't understand. That's why the operator immediately gave a cutoff, and we got into safing.
Okay, we'll go to Irene Klotz here, and then Will Robinson-Smith, and then we'll take a few more from the phone.
Hi, Irene Klotz with Aviation Week. I have a question first for Charlie or John. You ended up adjusting the timing for the wet dress because of the cold, but then did the wet dress in the really cold. Can you just explain a little bit about what you were doing during those 2 days, and if there was any equipment or systems that were close to qualification limits because of the cold? And for Amit, did the Falcon 9 upper stage anomaly yesterday do anything for your planning for Crew 12 launch? Thanks.
I'll do the Falcon 9 first, guys. Let me hand it to you guys. Yeah, thanks, Irene. Yeah, we did. SpaceX did a report as soon as it happened on a Starlink flight that they had an upper stage anomaly. They're working that with the FAA. So I don't want to get in front of that. The FAA is the lead investigative body. We do have our teams with commercial crew embedded in that investigation. And so in terms of how it affects our plans for Crew 12, et cetera, we're pressing towards our Crew 12 window. We're planning towards, just a week, a little bit more than a week from now to start that preparation. But again, that's going to be contingent on the return to flight rationale, which we're heavily partnered with both the FAA and SpaceX.
All right, the 2 days that we delayed wet dress. So let me say a couple things that weren't part of your question, but I'm really proud of the team that worked so hard to get to wet dress early. Right, we looked at what we could do to get there early. Our team had the work done. We were prepared to do wet dress 2 days earlier than we actually did it. And so that actually ended up being a wonderful thing. Now, the weather wasn't so wonderful, right? We were in unprecedented cold here in the state of Florida. We were very deliberate about looking at the weather and determining if we were in a configuration to do the test. Originally would have been, our T0 would have been Saturday evening when we ended up doing our call to stations. If you recall, on Saturday evening, it was very cold and it was very windy, and we did look at the weather and look at our criteria. The main criteria there for a wet dress, which is different than launch. On launch day, you absolutely have requirements for temperature and winds and other things. For wet dress, we did look at our temperatures because we needed to determine if we were within our certification limits for the ground hardware as well as for the flight hardware, and we looked at winds, and winds was really the more concerning item. There was 37.5 knots was what we were looking at as our constraint. And that was the primary driver for why we moved the wet dress originally from Saturday to Monday. And that was a great call because those of you who were here in the state of Florida during that time, you know that we had 50-plus knot winds on Saturday night. And so that would not have been a good configuration for us to be tanked in. It certainly would not have been a good configuration for us to send our closeout crew to the pad. And so that was part of the consideration for moving it. In terms of how did things go, we certainly saw in some of our, I'll say, pneumatic equipment, right, that is sensitive to temperatures. You know, we saw some fluctuation in some of our regs, but we have as part of the configuration and part of the control on those, they have some automatic or E-reg control that accounts for changes in temperature and pressure. And so we were able to manage all of that. There wasn't anything significant that I would say came out of yesterday other than, you know, activation of some heaters and those types of things. In terms of protecting the vehicle, we had purge go into the aft skirts during the, during the cold weather period. Sorry.
You need water, Charlie. Here you go.
Sorry about that. We had purge go into the vehicle. We had heaters configured. So in terms of taking care of the hardware at the pad, we had all the right things in place.
Okay, let's go over here to Will Robinson-Smith.
Hi, Will Robinson-Smith with Spaceflight Now. Thank you for taking the time to talk with us. A question first to Charlie and then a second to Amit. For Charlie, in the blog post that came out sort of summarizing wet dress yesterday, it mentioned that there were troubleshooting issues regarding to audio comms across the ground teams that have been present for the past few weeks, including during WDR. Can you characterize what those were, and are they the same or different than what we're seeing during CDDT in the VAB? And then for Amit, as you're looking towards the future of SLS, bringing in the exploration upper stage, I know the green run is coming up for that in the somewhat near future. Can you talk about some of the planning to maybe nip some of the issues that you've had with the vehicle in the bud for that second version of SLS that's coming down the pike to hopefully make the process to getting to launch a little bit easier? Thanks.
You need a break.
Yeah, I'll go ahead and then I'll do
sure.
the
No, it's good. We're looking at the production there for what we're doing at Stennis and how to make those tests more efficient. In fact, we came up with a unique nozzle config so we can do sea level testing of the vacuum engines to make that a little bit better. We'll see how that works. But across the board, we're trying to learn manufacturing fabrication techniques to make that more quick too. I mean, these are big circumferential welds. The diameter is pretty large. We're using a slightly thinner material because we're very mass sensitive there, and so we're learning those things both at Michoud and we're configuring the rigs at Stennis. But I mean, as we go, as we learn every core stage, and is a little bit different, right? As was pointed out earlier, it's an experimental vehicle, and just I'm reminded again, for almost 4 days and 40 years from Challenger, nobody sitting in one of these chairs needs to be calling any of these vehicles operational. So, Charlie?
Yeah, so the comm issue that I believe you're referring to is a few days before wet dress, and I forget now exactly how many, but we had a significant comm outage in LC-39 with the ground communication system, and that's the OIS loops that we use to communicate across our teams, both here at Kennedy and then back to our support centers across the country. And so we ended up calling in, I'll say, a suite of experts to go look at what might be causing that outage, and it really ended up being I'll say a series of events that had happened, and it was within the and I'm probably not the right person to answer this in this level of detail, but let me just say that it was in the kind of the details of the code. It was an edge case where you had a series of events that had to line up just perfect, and they did, and it ended up taking out our one of our LC39 communication servers. So the team did a great job, pulled in a lot of experts, including the supplier of this equipment and NASA experts from across the country. They did a deep dive on all of this, were able to diagnose the root cause right away, put a series of workarounds in place, and I'm happy to report that the comm worked fine during the wet dress rehearsal. And wet dress and launch are a great test case, because if you think about, when you're doing a single test, you might have a handful, maybe you got 30, 40 users, but on wet dress day, you've got centers across the country. We're all tied together. You've got hundreds, maybe thousands of users. So there's a big load on the system, and it worked really well. So the team did a great job resolving that issue.
Okay, we'll go back to the phone bridge, and we'll take a question from Micah Maidenberg with the Wall Street Journal.
Hey, thanks, Rachel. Maybe for Charlie or John, could you talk about some of the top items the team did not get to practice with the rehearsal stopping when it did? And do you actually need to get closer to or hit that 33-second mark during a rehearsal before an actual launch? Thanks a lot.
Maybe it's a good honeycat question.
I'll take it. So what are the things that we didn't get to do yesterday that we wanted to do? Well, let's talk about the things that we did. So we loaded the core stage and the upper stage with hydrogen, got to replenish. We loaded LOX, upper stage and core, got to replenish. What are the things we didn't do? We wanted to get through terminal count. We wanted to get inside of terminal count. We wanted to hold, and we wanted to verify our 3-minute hold capability, which is that you've got all of your cryoprop systems in a launch-ready state, and you can hold them there for up to 3 minutes. And we wanted to demonstrate that capability. We wanted to demonstrate a recycle, which is we would go down, have a planned cutoff in the countdown, come back and retarget a new T0 and be able to demonstrate that within the launch window. Didn't get a chance to do that. And then we would come down, do the handoff to ALS, and then cut off shortly thereafter. So I would say those are probably the three things that we had intended to do yesterday that we did not get an opportunity to do. And we'll target doing those in the next wet dress.
The next question is from Denise Chow with NBC News.
Hi, thanks so much. It sounds like for now work will be happening out at the pad, but I was curious if you have any early indications yet about whether you might need to roll back to the VAB. And then if you guys need it, are there launch opportunities beyond April that are available?
Yeah, I'll take the first stab at that. As I said earlier, right now it looks like the work that needs to be done can be done out at the pad. So we're gonna assess that. If that changes, we'll let people know. But that's the intent. As far as the launch opportunities, I know we've published what those opportunities and what the available dates are that could be targeted. We published those for February, March, and April. We've got opportunities in every month, several days. So, if necessary, we'll go beyond that. But yeah, there are opportunities. We do have, as you know, constraints on a variety of different constraints that determine just how many days within the lunar month we have available for launching. You've seen for February, March, and April, it's on the order of about 5 or 6 days. It'll be something similar. It varies month to month, but yes, there are additional opportunities.
Okay, next on the phone we have Anthony Leone with Spectrum 13.
Hello, and thank you very much for taking our calls today. With the leak issues that Artemis 1 and 2 have faced, will this reinforce NASA's consideration of using a different vehicle for Artemis 3, such as Blue Origin's Blue Moon lunar lander, which was something that then acting Administrator Sean Duffy talked about? Thank you.
Yeah, sure. So we are, of course, heavily partnered with Blue Origin and SpaceX and other super heavy lift launch vehicle providers. They're integral to our architecture. So we're going to continue to partner with them and share learnings and implement and cut them into our mission plan. So that's certainly true. Changing commodity on SLS or changing the design in that severe way will probably disable the production significantly. And make a change, you expect a change. We're as discussed earlier, it's hard enough for us to get into a flight-like configuration in a lot of these tests, and so now putting a big design square wave into it, I'm not sure would have the value that we'd expect. What we really want to do is let industry innovate on their own machines, and then when they're ready to support our missions, we'll cut them into the architecture and use them as we need to.
Okay, next on the phone we have Marcia Smith with Space Policy Online.
Thanks so much. Could you tell us how long you can keep the stack out at the pad? And I seem to recall that on Artemis 1, one of the factors was you needed to change the batteries on the flight termination system. Is that still an issue this time, or have you found a way around that?
Sure.
There are some batteries with flight termination that will need servicing, but we talked earlier about the pad access that we now have available.
Or, that could just stop working.
So there are some things that we can do servicing out at the pad. I will say that we do have other batteries. For example, the inner cryogenic propulsion stage, our upper stage, that those batteries will need to be serviced at some point. And so that if we go beyond the March time window, we probably would have to roll back in order to access those batteries. That's anticipated right now. So, yeah. Did you want to add to that, Charlie?
No, I think you covered it.
Okay, we'll take one more on the phone and then come back into the room. Next question is from Josh Dinner with Space.com.
Hi, thank you so much. Just a clarification question. You mentioned the quick disconnect. Is that the same component that caused issues with Artemis 1? And is it a piece of ground equipment that would have been refurbished or replaced after that launch? Or is it the same physical piece of hardware?
So it's different hardware on the flight side. It's same. The major components are similar on the ground side. There's probably some small parts and things like that that get refreshed.
Okay, we'll come back to the room here in the white sweater.
Hi, thanks so much. Jackie Waddles with CNN. A question for Mr. Honeycutt. You mentioned that there were some minor risk acceptance issues that the MMT worked through. Curious, could you give us insight into any of those and how the MMT discussed and what you communicated?
Yeah, Charlie talked about launch conditions versus testing in wet dress conditions. The majority of those were things like purge temperatures being out of limit just a little bit, and that doesn't bother us because those are really what's required to fly. They were pretty minor, but our process drives us where we're violating any launch commit criteria, taking a waiver, or there's risk acceptance involved. Charlie and her team bring that forward to the MMT.
Okay, we'll come on this side, third row.
Yes, Zachary Albert with the Launchpad from Canada. For Charlie, looking forward to the next wet dress rehearsals and then a launch attempt, can you take us through what the limitations are for, if we get into tanking, what the limitations to recycle for another opportunity on another day? Artemis 1, I know we heard 24, 48 hours. Also, looking towards the vehicle, are there any waivers that are maybe approaching a deadline that we'd have to look at? With Artemis 1, big one was the SRBs. Are we approaching any of those cutoff timelines that we'd have to look at some sort of waiver?
So I'll probably invoke the panel for some of the greater waiver pieces, but I will talk about the recycle capability. So we have two things that in a wet dress that we do, and the first is, or the plan was to come through a nominal count, because on a real launch day, one of the things that we can do is that we come through count. We have a 2-hour launch window, provided that you have enough window to do this. If you had an issue where you had a cutoff, in the middle of your term count, you have the ability to go get back into fill, get your tanks topped off. If it was something that you could clear, explain, work your way through, and then retarget a new T0. That is not a capability that we had demonstrated during Artemis 1. Thankfully, on Artemis 1 launch night, we came through terminal count without an issue at all and didn't need that capability. But we wanted to demonstrate. We've done it a ton of times in sims, time and time again. It's part of our normal sim cadence is to go through and do a recycle, but we've never done it with the hardware. So we wanted to demonstrate that. So that recycle is you are coming through term count, you are going back, and you're going to retarget another T0 within that same 2-hour window. The difference when you were talking about the 48-hour scrub that we had, that is our turnaround between launch attempts. And yes, we do have a very different capability this time around. And before, we utilized somewhere between, depending on when you scrub, somewhere between 250,000, 300,000 gallons of hydrogen. We have losses just in boil off. And so you have to replenish that. And during Artemis 1, that was about 30 tankers worth of hydrogen that we had to roll into the pad. We did about 20 hours of replenishment ops, and that set us up for a 48-hour scrub turnaround. That also puts a big demand on the suppliers. So that's a tough turn for really everyone involved. So we built the new 1.4 million gallon hydrogen sphere. Again, first time we'd ever used it, we refer to it as our loading sphere because that's how we intend to load the vehicle, and we use the old sphere to store hydrogen. So when we have a scrub, we can instead of taking those 30 tankers, we can push a couple of 100,000 gallons of hydrogen from one sphere to the other and be ready for the next attempt. And so we do have a 24-hour scrub turnaround capability for Artemis 2 as a result of that new hydrogen sphere.
Yeah, probably the biggest one you mentioned was the booster. So the booster office does a really good job of staying way ahead of us on when our need is and doing their assessments. So for the near term, we're still good. If we start seeing where we may bump up against that, they'll go reassess. But those assessments have all been positive to date. Some of the other areas you've already heard about, batteries, and then soft good, the Moon to Mars Enterprise does a great job tracking all those life limit items. So I don't see any concern out there right now.
Specifically, I think the cast life is good till 28 on the boosters. I think for this pair, and then slump. You worry about slump, just propellant grain migration, but we can measure that as we go, so we can actually take a witness and see if we're getting any migration. We're not seeing any of that right now. A handful of other things on the vehicle, on the spacecraft, like the active the scrubbing capability of the sorbent material and the CO2 beds is also something we watch, but we've checked that through the middle of 27, so we got a lot of margin there.
We'll go back to the phone bridge to the next question from Alicia Sowers with Mashable.
Hi, thanks for taking my question. My initial question was going to be about those ground communication dropouts, but since that's already been answered, I was wondering, just sitting at the pad while this work is being completed, is there increased risk of damage to hardware and electronics on SLS through, exposure to these extreme temperatures and, weather elements?
Take a shot and I'll hand it over to John. So one of the things about having space hardware is, that tank is rated for hydrogen at minus 423 degrees. So when you stack that up against a local forecast of 25 to 27, there's certainly things we take into account as it relates to flying. But sitting out at the pad, it's in pretty good shape, especially with the purges on the vehicle. So I think that's I don't know if you have anything.
Yeah, I mean, when we go through our testing and certification processes, we account for all the conditions that we could experience out at the pad, and even back for Artemis 1, when we had the high winds from the threat of the hurricane coming through, we did the assessment and we said, hey, it's safer to stay at the pad than just take another rollback, right?
Cat 1 hurricane, right? So
yeah.
That'll do. We also have lighting protection. All that's we protect for. We don't do it carelessly, but I think the vehicle's pretty robust against those conditions.
We'll take one last question on the phone from Paul Brinkman with Aerospace America magazine.
Hi, yes. I would like, could somebody please explain in this context how the leak threshold is determined? I believe 16% was mentioned. What exactly is the risk of a leak at 16%? Just why precisely the countdown was terminated in that case?
I can take a shot at that, or John, if you want to add.
Yeah, what I would tell you, in the shuttle program, I always had scratched my head about why we had such a low requirement at 4%. We challenged the team to go back and do testing relative to that. These small volumes, I think it helps you to understand where we have these leaks. They're purged. They do have a vent coming out of them. Obviously, it's somewhere the leak's concentration's 100%, but when you get a leak, it mixes with the purge and then it vents to atmosphere. So we wanted to understand how these small volumes are operate, and what the threat and what kind of energy you can have, and whether you can have just some sort of a small flame front that can't sustain itself, or something much worse than that. And when we did those tests, and it was fascinating to go through the data review with the team and see the imagery that they got. But that's where we got comfortable with this 16% limit. I can assure you we had some margin associated with that too. If you got something else, go ahead.
I was just going to say, we were really fortunate that one of the things that the SLS program, they came up with a test campaign that actually looked at that cavity, the characteristics of the cavity, the purge in the cavity, and introduced, and this was with an outside test agency, that introduced hydrogen to see when you could actually get it to ignite. And at 16%, you could not, and that's what the limits were based on. It was based on test data.
All right, that's all the time we have for today. I want to thank our participants for being here today. We will share more progress on our Artemis blog, so you can stay tuned there for additional updates.
Can I listen to that last thing again, guys, if you don't mind?
Could somebody...
We'll take one last question on the phone from Paul Brinkman with Aerospace America magazine.
Hi, yes. I would like, could somebody please explain in this context how the leak threshold is determined? I believe 16% was mentioned. What exactly is the risk of a leak at 16%? Just why precisely the countdown was terminated in that case?
I can take a shot at that, or John, if you want to add.
Yeah, what I would tell you, in the shuttle program, I always had scratched my head about why we had such a low requirement at 4%. We challenged the team to go back and do testing relative to that. These small volumes, I think it helps you to understand where we have these leaks. They're purged. They do have a vent coming out of them. Obviously, it's somewhere the leak's concentration's 100%, but when you get a leak, it mixes with the purge and then it vents to atmosphere. So we wanted to understand how these small volumes are operate, and what the threat and what kind of energy you can have, and whether you can have just some sort of a small flame front that can't sustain itself, or something much worse than that. And when we did those tests, and it was fascinating to go through the data review with the team and see the imagery that they got. But that's where we got comfortable with this 16% limit. I can assure you we had some margin associated with that too. If you got something else, go ahead.
I was just going to say, we were really fortunate that one of the things that the SLS program, they came up with a test campaign that actually looked at that cavity, the characteristics of the cavity, the purge in the cavity, and introduced, and this was with an outside test agency that introduced hydrogen to see when you could actually get it to ignite. And at 16%, you could not, and that's what the limits were based on. It was based on test data.
All right, that's all the time we have for today. I want to thank our participants.
That's okay. Dude, there was a lot of there was a lot of stuff in that press conference that I was kind of just like, what? Really? Yeah, 4% H2 concentration was on the shuttle, so they raised it to 16. Well, okay. Candace, okay. We could start there with that last question. That last question really confused me. It was a good question, for what it's worth. Okay, you guys tell me if I'm following this right. This isn't... I'm trying to understand. Okay, so the SLS has... The SLS core stage has basically shuttle umbilicals on it. What they use to fuel SLS is basically the same thing. It's the same thing as the shuttle. Instead of being on the sides like the shuttle, it's at the front, because it's not a space shuttle. The core stage isn't a space shuttle. So during the shuttle program, it was a 4% leak rate, and they looked at that and said, well, we wonder why. Why is that a leak rate? Let's go test it. Okay, we can get it up to 16, and it won't ignite, so that's our constraint. That's fair, but did we look into why this space shuttle was 4%? Was it arbitrary? Was there some type of analysis done? Maybe the shuttles was at 4% for a very good reason. That's where he said it was arbitrary. Is it? 16% can leak. Okay, just a little bit of clarification on the leaks, guys. So, the hydrogen umbilical has 3 main pipes on it. Okay, so my thumb here is your main umbilical. That's a 12-inch line. That's the main fuel line. That's where hydrogen goes in. You have your bleed line, which is an 8-inch line, and a purge line. Or no, the bleed line's... What was it? There's a bleed line and a purge line. There's 2... The bleed line is for low flow. The purge line is for high flow. Okay? We're talking about... When they say 16% leak rate, they're not talking about 16% of the fuel leaking out of the vehicle during fueling operations. The 4-inch bleed, that's right. There's a 12, an 8, and a 4. Thank you. The 4 is for slow fill, the 8 is for high flow, fast fill, and the 12 is for fueling. Here, I can show you a picture of it. Give me a moment. So this is what it looked like on the space shuttle. This is the T0 carrier umbilical plate. It's on Flickr. So there it is on the shuttle. This is very similar, but it's not exactly the same, but this is the idea. So you have your main, this is locks. This is the lock side of things, which is why there's a blank over here. So main, purge, bleed. All right, this is the shuttle. That's the locks line. That's the T0. So it's the T1 carrier umbilical, but you get the idea. All these other ports are different power connections, and then you have hydrazine for the ohms pods. Hydrazine filling up there, no, purging. Excuse me, it's not filling. They'd fill the ohms pods on the shuttle before it got to the pad. So when they're talking about leak rate, dudes, they're not talking about like 16% of the fuel is leaking. When you pump hydrogen in, you have to recirculate it because a lot of that hydrogen is going to turn to gas, okay? It's going to turn to gas until you have the tank pretty much fully fueled, and even then, liquid hydrogen is boiling, so you have to give it a place to go. You have to have a scavenging system. The bleed and the purge lines are the scavenging system. When they're talking about leak rate, they're talking about the scavenging system flow rate, a percentage of the scavenging system flow rate, meaning that 16% of the gaseous hydrogen is leaking out of the purge line, not the main fuel line, okay? That's what that means. Now, with all that being said, fellas, I'm just going to go outright and say it. That's dumb. That's dumb that they have the same problem as they did before. I can't believe with 3 years of testing that this wasn't figured out. Like, I don't mean to be that guy and be like, oh, I know more than you. That's a problem. That's a big problem if you didn't have this figured out. That's I don't understand how. Yeah, exactly, Happy Badgers. Arian 6 does this with no problems. Arian 5 does it with no problems. New Shepard does it with no problem. New Glenn does this with no problem. Delta 4 had other problems. The pad was a pile of junk. But Delta 4 didn't do this. Delta 4 didn't have this leaking issue. What? And Delta 4 uses shuttle-derived umbilicals, if I'm remembering correctly. What the heck? Why does this vehicle have this problem? Why is the shuttle the only one with and SLS the only ones with these issues? It's very, very interesting here. And what? 1 mole with 0.6 mole leaking of hydrogen. Yeah, there you go. No, Farm, I don't really think it's anything like that. Centaur never has an issue with this. They load hydrogen all the time. ULA has no problems with it, with Atlas or Vulcan. I don't understand. Why is this like this? Why does this do this on this particular vehicle? The only thing I can default to is that the shuttle carrier umbilical is a pile of junk. Because the sheer volume, that might have something to do with it. I would actually guess that it's probably volume. Interesting, Gary. How did these other rockets load hydrogen? It's all pressure driven. Yeah, Kevin, it's all pressure driven. Volume is my guess, guys, now that I'm thinking about it. Yeah, Rares, that's probably the right idea. It's probably just the sheer volume. You probably have to go into a high flow. You have to go into a high flow state. Basically, they got to fill the hydrogen fast. If they keep slow filling it, it's going to take days to fill it, and the propellant will just boil off. So you're really constrained here. I just don't understand how you wouldn't test for this. I really don't get that. I want to go back in that press conference. I'll go back to Marcia's initial question when they started doing that. I just don't get it. Deadbringer, if you've done your homework correctly, they measure the H2 concentration in the umbilical plate purge flow. They flow gaseous nitrogen at a constant flow rate in the seal, so it's very likely it's 16 in a H2N2 mixture. Fast fill increases pressure, so more leaking and higher percentage. That's what I'm coming. Yeah, it's not like they're leaking fuel out of it. It's the purging system and the bleed system, and even that seems to be N2 purged. They want the same fill time as the shuttle, so they run higher pressures on the same plate. Possible. It seems like the seal was working when it left the VAB, and basically the vibrations from the crawler transporter potentially undid the seal. Jeez, I don't even want to know how many times that happened. That probably happened with the space shuttle program. It's crazy. Yeah, let me just...
Question queue with star
I just want to listen to this one more time.
Let's start over here with Marcia Dunn.
Hello, Marcia Dunn, Associated Press. 3 years seems like a long time, enough time to wring out any hydrogen leak problems. Why wasn't there more aggressive testing checks since Artemis 1? And... sorry, I'm just losing my thought here. If you could just explain how you can still be having the same problem 3 years later. Thanks.
Yeah, so in my old job as the course or the SLS manager, after Artemis 1 and the challenges we had with the leaks, we took a pretty aggressive approach, as Charlie mentioned, to do some component level testing with these valves and the seals, and try to understand their behavior and their tolerance for surface finish and FOD or debris or scratches or something like that, right? And so we got a good handle on that relative to how we install the flight side and the ground side interface there, but on the ground, we're pretty limited as to how much realism we can put into the test.
Why?
And then at the end of the day, and what I would say to that is, we try to test like we fly, but this interface is a very complex interface, and when you're dealing with hydrogen, it's a small molecule, it's highly energetic, and we like it for that reason, and we do the best we can. And actually, this one caught us off guard, and the initial things that we were seeing, and the technical team felt like we either had some sort of misalignment or some sort of deformation or debris on the seal.
Yeah. Yeah, your testing wasn't good enough. Your analysis was terrible. That was very bad. It shows. John Honeycutt's the SLS program manager, and I think he is realizing as he answered this question that he is in a lot of doo-doo. Yeah, I think that body language pretty much speaks volumes there. Probably misalignment from the 8-hour crawler ride. Yeah, but Rares, look, fellas, I'm just gonna go out and say it. Like, look, that's terrible testing. It's terrible testing. That is terrible flight rationale. This entire press conference is full of terrible, terrible flight rationale. And I'm not trying to say I could do any better or anything like that. Look, this stuff has to be perfect. It has to be perfect. And if you're going to accept less than perfection, you're opening up the door for deviant engineering. You're opening up the door for leak rates that are beyond what you want. You're opening up the door for the hatch seal not working. it's all over the place. Like, yeah, exactly. Yeah, see, Vancaro, exactly. So, guys, over in the YouTube chat, Rare said probably misalignment from the 8-hour crawler ride. And Vancaro asked the thing that you said right after that. Is the crawler ride unexpected? Is it unexpected? No. You know it's gonna move around during the transport. So why not check it again when it's at the pad? Did you check it again at the pad? If you know that behavior is there, why not test for it? That's what I mean. You're taking unnecessary risk there. If you think that the crawler transporter moving the entire thing can unseat a seal or something, why even risk the wet dress rehearsal? Why do that? Bespoke one-off parts. Yeah, that really, I mean, Deadbringer, that's what I'm getting to, dude. The real problem here is that every one of these launches is a bespoke vehicle. It might as well be a different thing. And I know I said something different going up to this wet dress rehearsal. I said that they'll probably be fine. They'll probably have the vast majority of these problems figured out. And it seems like they did. It seems like they did pretty good homework here, but also at the same time, you know, without standardized hardware, without precise processing flow here, you're gonna run into these problems. Like, it really comes down to SLS needs to fly more. That's really it. He needs to fly more. I would say that this problem probably would have been found if they had green run this core stage. Yeah, it probably would have been figured out. They ran into the same issue last time. It is a slightly different thing leaking this time, Hellfish, but yes, for the most part. It's a bespoke vehicle. It needs to fly more. Second paragraph. The flight rate is the lowest of any NASA-designed vehicle. I know, Phil. I know. No top to bottom checkout after arriving at the launch site. They can't, Scott. They don't have a mobile service structure. The fact that they're still having this problem they discovered in Artemis 1 is a disgrace. I mean, Murray, it's always more complicated than that to be like, oh, this problem happened again. That's dumb. I will say that hydrogen is a complicated thing to deal with, right? But also, I kind of agree with you. Like, I don't want to reduce it. You should never try to reduce it to its base element like that. Like, oh, well, this is happening again. That's dumb. It is pretty stupid. And like I said, John Honeycutt's body language there is all I need to know. He screwed up. They screwed up. Their analysis wasn't good enough. And now they pushed a moon mission because your analysis on that umbilical sucks. It was terrible. He said they tested it. How many times did you test this? That umbilical should have been attached and detached and flowing hydrogen every day. Every day, or at least once a week since Artemis 2, to make sure that that problem never happens again. How many tests did you do? How many tests did you test as you fly? How many tests did you do? You studied the precision tolerances of the umbilicals. All right. That's great. You're looking at the precise tolerance of the umbilical. We know it's complicated. We get it. It's a moon rocket. I understand that. You're NASA. You are NASA. Hello. You're NASA. What do you mean? You can't figure this out? Every other rocket has no problems with this. I mean, SpaceX lost 2 space years to COP. Yeah, and I called them out for it, King. This behavior is not... This isn't good. Honestly, I'm not really happy with that press conference, guys, and neither should you be. I'm not happy with it. That's unacceptable. Brother, you've had 3 years to get that figured out, and you haven't figured it out. This is why I said, like, oh, they should have it figured out. They didn't have it figured out. That's ridiculous. Now, granted, it's not leaking in the exact same spot that it was during Artemis 1. But also, how, like, they said they thought that maybe the crawler transporter did it. Maybe it was FOD getting in there during the ride out to the pad. Okay. How do you not know that that's going to happen? I don't understand. That's terrible, objectively terrible analysis. I've seen that already, Squall. It was just linked probably less than 5 minutes ago, dude. I've seen it already. We saw it at the beginning of the stream. What are you trying to get my attention for? I'm confused. Jared said the flight rate is the lowest of any NASA-designed vehicle, and that should be a topic of discussion. It's why we're undertaking wet dress rehearsals, pre-flight readiness review, and a flight readiness review, and why we will not press to launch until we're absolutely ready. No, you weren't here? No, somebody linked it just a second ago, dude. What do you mean you weren't here? Your messages were right after it. Don't lie to me, man. No, I'm just kidding. Don't worry about it. I linked an Ares 1 hydrogen paper in your Discord. Okay. What I found about the 4% concentration for Ares 1. So in theory, if there's more nitrogen getting purged, there is possible bigger concentration of hydrogen. But again, I'm not sure if it's much relevant. The only thing I found with a quick search, though. Yeah, I got you, Yuri. Thank you. I appreciate that, Swell. Thank you. Yeah, no, I've seen it. I saw what he said. I read the whole tweet at the beginning of the stream. Lack of hardware is at the core of the issues with not being able to retest Orion's heat shield too. Yep. Yeah, that's really... But... I'm just not really getting any sense of urgency from anybody here. Like, what do I mean? Look, you don't want to pressure your engineers and your program managers and stuff into hitting deadlines. You really don't want to do that because that could, screw with their judgment. But, guys, I'll be 100% honest with you. No one has pressured anybody here about getting this schedule stuff right, and it still screws up. I'm disturbed so bad. How many physical tests do they actually do? That's what I'm really wondering, Beats. They were talking like, oh, we tested the umbilical. We tested the umbilical. Well, I mean, obviously you didn't. Like, obviously you didn't. Like, obviously you didn't because it doesn't work. So maybe you did, but your testing wasn't good enough. Do you know what you're testing for? That's honestly where I'm getting at. Like, I mean, obviously they're not going to sit up here and say every single test that they did, right? I get it. But also at the same time, like, you've had 3 years to figure this out. If somebody put me on the umbilical and said, make sure this doesn't leak, I would be fighting 60, 70 hours a week to make sure that son of a bitch doesn't leak. I don't give a frick who I'd have to ask. I don't give a frick who I'd figure it out, dude. Right? Your name's on it. But, and I think John understands that. I think he realizes, like, oh, crap, this is my fault. And he realized it in the middle of the interview. He was like, oh, damn. Like, body language is very telling. He was looking at the ground, which means you screwed up, dude. What are the dangers of a high leak rate? Hydrogen will pool wherever you don't allow it to, wherever you don't want it to pool if you don't give it a place to burn off. I'm not clear how they got from a 4% to 16% tolerance. Yeah, that's multiplanetary. They said that the 4% on the shuttle was arbitrary, and that's no, it's not. It's not arbitrary. No, you don't. No, it was there for a reason. Most likely because the shuttle is a very, very complicated piece of equipment, and you don't even want the chance of hydrogen getting anywhere inside of your MPS. on the shuttle, main propulsion system. So the engine room on the shuttle. The other thing that I really don't like is that they reinforced a modus operandi of testing as you fly, and then started the wet dress rehearsal when it was too cold, when it would have been too cold for flight conditions. Yeah, I got a problem with that. Yeah, that's dumb. Why would you do that? Why? Well, Usopp, the thing to understand is that hydrogen is going to leak. It's going to leak. You just have to. That is an intended thing because of the complexity of dealing with liquid and gaseous hydrogen. It's going to leak. The thing is, you have purge and bleed lines to pick up the leak. That's on purpose. But these purge and bleed lines, you're moving around gaseous hydrogen. It's really hard to get them to seal, right? But, like, this is what I just don't get. I just don't understand. You know it's hard to seal. You know it's a pain in the butt. Do something about it. You know, oh, we tested the precision tolerances of the parts. Tolerance is not your issue here. The seal doesn't work. Like, the seal doesn't work. Tolerance is not the issue here. Whatever tolerances it were wasn't a thing. It's clearly not tolerances here. It's clearly how the seals on that umbilical are seating correctly. I mean, you could argue that has to do with tolerance, but the tolerance is on it. But I disagree. I think the seal design is bad. But I don't know. They got it to work on Artemis 1, but now you have the same problem again. Which tells me that your processing flow either sucks or your testing, your analytical testing and your on-the-ground testing was nowhere near good enough to take this into account. So, you know, that what I'm basically getting down to, I'm going to get down to brass tacks. What the frick have you been doing for the last 3 years? What have you been doing? What have you been doing? Like, honestly, it's an honest question. Do you know the materials of the LH steel seals are made from? It's rubber and aluminum, dude. Good thing you don't work for NASA, I guess, dude. I ain't saying I can do better, but honestly, at the same time, you're not doing your job, and it shows. Like, how much does that melon farmer get paid, dude? How much he get paid? Probably more than us. Man, I'd love to get paid double what I make here and be wrong about stuff. And then delay a moon mission by a month because you didn't do your homework. Yeah, B. Dean, that's kind of what I'm getting at here. I am noticing a very large amount of not testing as you fly. I'm noticing a very large amount of it here. Like, you can't screw around with this stuff. It has to be perfect. It's like, it's not even a judgment call. You can't leave anything to chance. There are commercial contractors that use hydrogen regularly, and we don't hear about leaks about them. So, yeah, the 3L, that means they're either A, not telling us and it happens, or B, they've had this problem. They have this problem under control. So why does theirs work and this not work? You know what I mean? Last, what do you... And he referenced Challenger in the Q&A like he knew it was too cold. Yeah, I don't... I'd want to listen to what Amit Christia had to say about that. I only caught the tail end of it, but I was like, what? Why would you even go there? Why would you even talk about that? I don't understand. Like, yeah, Fluffy, it's really unacceptable. Like, brother, this thing should be tidied up. It should have worked the first try. Like, especially after Artemis 1. Like, You have flight data on the table. You know the behaviors. You guys you clearly fixed the problem with Artemis 1, and then you allowed the problem to happen again for Artemis 2. That means your analysis on getting those umbilicals to seal, which is based off of flight data, which is ridiculous to me, wasn't good enough. What have you been doing? Why does this mission seem low-key cursed? I don't know. Well, they only ever had 2 core stages. Can't test like you fly if you have no flight vehicle. That's, Black Eagle, that's the underlying problem here. There's just not, you're not hardware rich enough. And this is what I mean. 1 green run test was not good enough. You need to green run every single core at this point. Because it's very clear to me that it's very clear to me that this is, whatever your testing regime is not good enough. It's not good enough. The whole thing, this is all terrible. I mean, but here's the thing. The vast majority of those systems did work correctly. You know, we're chasing a couple of small issues here. This is the flip side of this, guys. We're chasing a couple of small things here. How many people will be losing their jobs after this? Probably no one. I don't see how the green run could have fixed it. Yuri, a green run would have been more data on tanking. It's very clear that they need more data because their testing isn't good enough. So I think that B2 test stand, I think retooling it for the EUS was dumb. If you really want my honest opinion, that's really stupid. I think that thing should have been set up to, and every core stage should be test fired. You're using RS-25s. It's very clear that they can be reused. Just saying. He was referring to the vessel's experimental, and so were the shuttles. They should never have been deemed operational when he was referring to Challenger, i.e. they can't be complacent with anything. Yet they are. Okay, I get it, but they are also. Well, whoever inadvertently vented the counterbalance in the White Room may have a meeting with HR. Yeah, this... What this really seems like is that nobody wanted anybody to do testing until they had a full launch vehicle, right? And then when they had a full launch vehicle, that's when everybody started doing testing. And guess what? It shows. Yeah. They may be hiding a bigger issue. If they had the ability to create an environment to work on the seals at the pad, why wouldn't they do it once to get the pad just... Yeah, Jeff, that's my question. If you incorporated reseating that seal on the pad for Artemis 1, why the hell didn't you do it for Artemis 2? And then Artemis 2 had the same damn problem. Like, dude, definition of insanity, man. How did you not know this? Yeah, Nader, I don't know. I don't know if firing people is the solution here. Like, I'm not... Yeah, Deadbringer, dude, we could have told you that 3 years ago. How did nobody... And that's what I'm getting at, dude. Nobody had the wherewithal to be like, maybe... Jake break. Nobody had the wherewithal to be like, maybe we should do that just to make sure that it works. Like, at least 5 times as difficult can Knucklehead, yeah. You can't fire people for making a mistake. Yeah, TJ, these aren't mistakes. Some of these problems aren't mistakes, dude. They're not. They're not mistakes. They're people not doing their job. How much does the CT vibrate since it moves so slow? There are adverse vibrations that get moved through the vehicle. They did talk about that during Artemis 1. On a different note, how does Titan do? Titan's doing just fine. Yeah, we were playing this morning. It was a good time. I don't think they're going to roll back, Tycon. What the hell was that noise? I don't think they're going to roll back, dude. This is... Dude, I don't like it. I don't like it. And I'm not trying to concern troll, dudes. I'm not. I'm trying as hard as I can to not be like that. But, you know, the mission is off the table for the time being, so... Why? Okay, let me give you an example. They chose to tank the vehicle for the wet dress rehearsal. They had all this talk about testing as you fly, test as you fly. Okay, right? So you'd think that for your wet dress rehearsal, your temperature tanking criteria should be the exact same as a flight, right? But it wasn't. They filled it when it was too cold. Now, once again, that's fine. You can do that. Maybe the leak had something to do with that. Maybe the umbilical got too cold. Who knows, right? But also at the same time, like, that is introducing unnecessary risk. You're introducing unnecessary risk because you don't know for sure if the vehicle's going to work within your predefined temperature criteria. The whole point of a wet dress rehearsal is to validate your analytical analytical analysis is redundant. It's to validate your analysis on the vehicle's launch and commit criteria. That's the whole point. And yet we see, NASA ignoring the rules because, no, it's fine. No, that can be nothing but schedule pressure. That's unacceptable. It's unacceptable. I'm sorry, it is. This has to be perfect. There's no ifs, ands, or buts about it. And I ain't saying that I could do better. There's a reason why I'm sitting here whining about it on Twitch, okay? I understand that I probably couldn't do any better, but also at the same time, I know enough about this to know that you can't do stuff like that. That's not okay. The more I feel you working through this scenario, the more mad you seem. I just heard a lot of real conflicting information during that thing, King, and I was... dude, this is all over the place. And I think, it's not that I think, we talked about firing people for incompetent. It's not that I think that people are incompetent, dude. It's just, I think lack of flight rate here and literally no urgency at all to solve these problems due to lack of flight rate. To solve these problems with expediency and deliberateness is warranted because you don't know when the next one's going to launch. Who cares? Right? Like, I think the entire thing comes back to lack of flight rate, and it's really starting to show. It seems like there's a lack of discipline. Yeah, exactly, Hellfish. Like, dudes, you guys they had leaks on Artemis 1. They had the leak rate with the purge lines. Same exact problem. How did you not solve that in 3 years? It's unacceptable. It's unacceptable. It can't be like this, dude. It can't be like this. If you do something like, oh, it needs to be 40 degrees Fahrenheit. It's 38. Let's tank it anyway. It shouldn't be a problem, right? Or, oh, we have a little bit of a leak, right? The leak rate is expected. It was 4%, but we proved that it can be up to 16 before you hit combustion, right? Let's go, even though this umbilical was designed with the commit criteria of a 4% leak rate, let's do 16, even though it's the same exact umbilical on a different vehicle. That is doo-doo. That is doo-doo. That's terrible, and now that's terrible. No. What are you doing? Stop it. Those small stuff like that, dudes. Small stuff. Little things like that. A compromise, or a compromise over a compromise over a compromise over a compromise over a compromise. That's how aerospace disasters happen. That is the exact behavior to a T. Also, lack of a larger than component testing, submodel or module testing can help shake this out. I also suspect that using legacy hardware like the SES ground umbilical carrier, but modify it for SLS instead of engineering something that has to do with it. Well, I mean, Deadbringer, the whole point, yes, that has something to do with it. But dude, if you're making a shuttle-derived launch vehicle, the whole point is to go with their analysis. Why was the shuttle, if you're making a shuttle-derived launch vehicle for ground umbilical carrier plate, right? For ground umbilical carrier plate leak rates, the whole point of making a shuttle-derived vehicle is that the analysis has already been done for you, and it should be really easy if you just follow the same exact steps. Where did we go wrong? Where did we go wrong there? No, you see analysis on analysis because you thought the original shuttle analysis was arbitrary, even though the shuttle has 135 tanking missions on top of it and an MPTA mission on top of that, right? No, but it's arbitrary? No, it's clearly not. It's clearly there for a reason. But all of a sudden, you can have a threefold increase in leak rate and be cool with it? Based off of your testing? I don't want to talk about it, Nader, but yes, I'm noticing big problems all over the place, dude. I have to ask it. You know, how do you know that the heat shield analysis for the revamped flight regime is going to work? Yeah, I don't, yeah, Geek, what have you been doing? What have you been doing? Dude, if it was me, that umbilical would be tested 20 ways to Sunday. I just... Good vibes. I'm trying to give off good vibes as best as I can, King, but they're making it very difficult. And now that a mission campaign is basically off the table for another month, dude... I'm not gonna lie to you, man. I'm noticing a lot of red flags here. I agree, John. This is not okay. This changes that Wayne Hale Twitter interaction. Yeah, Brand. Yeah, exactly, right? See? You know, I'd give Wayne the benefit of the doubt, but also at the same time, there was a reason he said what he said. People don't invoke Challenger unless there's a very good reason. Honestly, after seeing this wet dress rehearsal and subsequent press conference, I'm not entirely sure that anybody here knows what's going on. Yeah, I guess, King. Why? Why would you go with a launch campaign for a wet dress rehearsal, which is a test to validate systems, and not adhere to your launch commit criteria? That is the dumbest thing I've ever heard in my life. Like, you guys know you're putting people on this, right? Like, there's going to be people on board, right? Like, we understand this. Did you hear the guy said that most of the components of the ground side umbilical is the same, at least the one as the last one? Yeah. They were so desperate to test that they ignored constraints. And guess what? You got a fluke. And now you have to sit here and face the media about answering why your wet dress rehearsal was a fluke. Because you started ignoring criteria, which is stupid. Oh. Goodness, how can these people be okay with this much slop? It's so bad, dude. And I don't know, maybe I'm overthinking it, dude. Maybe I'm wrong. The testing is nowhere near good enough. And it shows. It shows. Like, guys, the reason, like, I'm usually not so absolute in my analysis on situations here, but also physics doesn't lie. That's the thing about this, dude. You can't lie about engineering. You can't. Physics will keep you honest. Okay? So that guy, John Honeycutt, who I don't mind, he's usually a good dude. He's usually on it, right? He went up there and he said, we've done all kinds of testing with tolerances of stuff, but it still didn't work. Well, no, you didn't. No, you didn't. And if you did, it was a fool's errand because it still happened. No, you didn't. Your testing was not good enough. It was not adequate. Like, there's no other way to get around it. Physics doesn't lie. It doesn't lie. Whatever you did not fix the problem. So that means you were guessing. That means you were, we think this is going to fix it. Let's put it out on the pad and see what happens. Okay. You want to choose the iterative design approach. Guess what? SLS ain't made that way. That thing has to work. There's no getting around it. Like, I don't mean to put out bad vibes, guys, but I don't like it. I don't like this. You can't dick around with this stuff. Yeah, exactly, silly. You see that? That's not good, man. I don't like it. I'm noticing, frankly, terrible and sloppy analysis across the board here. Who's the engineer to his left? To John Honeycutt's left? So John Honeycutt's the SLS program manager. Charlie Blackwell Thompson is the launch control manager. She's the lead launch controller. I forget her name. She's the Moon to Mars, so she's like the Artemis. She's like an Artemis program manager. Amit Krisithia is, and I'm not saying his last name right. I apologize. He is the second in charge at NASA. He's Jared Isaacman's right-hand man. He shouldn't be able to say it's deformation or FOD. There should have been modular tests for that. Integration tests, checks at the pad. Yeah, Jim. Yeah, exactly. Exactly. This screams either A, lack of understanding of the problem, or B, just you don't, lack of understanding of the problem, or B, you didn't test it. You didn't do enough testing. Lori Blaze is her name. There you go, username, yeah. Iterative design, the same thing that plagued the Ford carriers, and honestly, all the government at times. Iterative design looks cheaper on the books, and anything the U.S. government does is low bidder. Yeah. Yeah, how those emails working? Whoops. Kshatriya. For what it's worth, I think it's Kshatriya. Yeah, that sounds right, Dino. See last. This is, it's unacceptable, dude. This is, you can't. No. I would not accept this. If somebody's like, yeah, it's a little bit too cold to do the wet dress rehearsal today, but everybody's here, so let's do it. I'd be like, no, you're fired. Get out of here. Go home. Go home. I don't want you here. Like, no. Unacceptable. And, people would hate me for it. If I was in charge, people would hate me for it. People think I'm a dick. Well, guess what? Yeah, I'm a dick because I don't want people to get hurt. Get the hell out of here. Yeah, Calcium, I don't know, dude. We've worked at an engineering firm for 15 years, Fluffy. You either work fast and sloppy or you work hard. Put in long hours and typically you get it figured out. Your work will show which you choose to take, period. Bingo. That's it, Fluffy. That's it, dude. Like, if they went to tank this thing and they had another problem somewhere else with the vehicle, right? It would show that they really, really did their homework to make sure that damn thing won't go above a 16% leak rate. But they didn't. They had a bigger leak rate this time. That tells me you have no idea what you're doing. And the people doing the analysis also have no idea what they're looking for. Yeah, workshop, exactly. Yeah, I know. That's the behavior that I'm getting at. It's not necessarily about the cold, but it's the mentality. That mentality is dangerous. Yeah, I can't believe Charlie Blackwell Thompson went up there and said, yeah, you know, our commit criteria for the wet dress rehearsal is, you know, it's not exactly within our launch commit criteria. So if we were going to launch today, we would have scrubbed. But we did the wet dress rehearsal anyway. No. You leave. Get out of here. Nope. No. No. That's not right. That is a huge, huge, huge problem. At least there's not a crew near it. Well, workshop, the reason why I'm being a pissant about this is because there is going to be crew on this rocket. There is going to be crew. You cannot get this wrong. You cannot get this wrong, period, full stop. Like, there's no... I mean, this is all bad, useless data. And you know what, King? You know what's kind of funny, dude? We were talking about the umbilical analysis. What if their choice to go to try and fill this up in cold invalidated all the umbilical analysis because they chose to do the wet dress rehearsal when it was too cold? If I were John Honeycutt, I'd be pissed because that makes him look like an idiot. That's also a viable thing. He was not happy. Like... Yeah, exactly, workshop. At 40, yeah, and we're at the 40th anniversary of it. Maybe that's why he looked so done. Yeah, because he was like, dude, anytime I could scrub through the video, just anytime you get a picture of him, he's looking at the ground. Look. Nah, dude, that's what I'm saying, man. Like, there is someone here that is rolling the dice, right? It's like we're playing Clue. You know what I mean? Who could be okay with an out-of-spec test? I mean, King, like I said, John may have done his job. And here's the thing. I've watched a lot of interviews with John Honeycutt. He generally doesn't dick around like this. Like, during the green run, he was very, very deliberate, and the green run worked fine. You know? I mean, they had one little bit of a snafu, but he admitted it, and he fixed it, and then they ran it, and it was great. Right? Yeah. He could have done everything right. Their analysis could have been right per NASA's own commit criteria, and because they chose to send it when it was too cold, that could have caused the leak. It's possible. I actually, now that I'm really formulating that, I'm actually willing to put money on it that happens, because like I said, John doesn't miss. He's a good engineer. I know he's a good engineer. I've seen his meetings before. He knows what he's talking about. Like, it's very rare. Watch him in other interviews. It's very rare for him to look like, crap. You know? I'd be very curious to who gave the go there for going when it was too cold and not adhering to launch commit criteria. That's really unacceptable. Like, failure is always an option. If you're not failing, you're not innovating enough. Guys, you say failure is not an option. I'd say that applies to missions, okay? Failure is not an option after you've launched the mission. You can't fail. Up until that point, sure, that's when you should be failing. It's absolutely an option. When people aren't flying on the rocket, that's absolutely an option. But not now. We're too far. They also said that if they heat the seal up, it started working again. They did say that, Crownless. That's weird. The commit would have to be from Charlie, right? You know, I'm curious to hear when she talked about that. Hold on.
Amount of work in Orion closeouts for where we were in wet dress. I mean, we were essentially configured for launch. That was always part of our plan.
Hold on.
because we wanted to limit the amount of work between WDR and our earliest launch opportunity. So in terms of a lot of work within Orion, there really wasn't a whole lot left between WDR and launch. We did have some late stow and some other things, and obviously the final configuration for launch relative to some of the crew equipment. But overall, we were in a, I would say, very close to launch configuration yesterday.
Okay, we'll take one more on the phone and then come back to this side of the room. The next question is from Eric Berger with Ars Technica.
Hi, thank you very much for doing this.
listen.
Earlier
I'm
today,
trying to
the
find it.
NASA administrator said of the SLS, the flight rate is the lowest of any NASA-designed vehicle, and that should be a topic of discussion. And so I'd like to ask about that. You know, going back to the green run years ago, I think that this is maybe the 7th or 8th time the SLS rocket has been fueled, at least the core stage, and all of these tankings have been pretty adventurous. So I'm just wondering, given the given the low flight rate, do you think launching this rocket is ever going to be more than an experimental process?
No, that's not what I wanted to hear. Okay, let's hear.
So, what we have learned during the Artemis tanking campaign is that this interface is sensitive to flow rates and pressures. We learned that during Artemis 1, and we saw the same thing. Yesterday. It was when we went to fast fill. We were in slow fill. We were within our limits and within our bands. It was when we transitioned to fast fill that we began to see the limits creeping up, or the concentrations within the cavity creeping up. And we did, was it a steady rate? I mean, it increased. We got up to, probably 12, 14%. And then when we got close to the 16%, that's when we did stop flow and revert, and decided to invoke our procedure for letting that interface warm up and then retrying it again. During Artemis 1, we found that sometimes that was very successful. I mean, that's a pressure-assisted seal, so sometimes letting it warm up and then putting some more pressure across it, you'll see the seal improve. And so that was the goal yesterday. When we tried it the second time, the performance was pretty similar. We have the ability, and what we do in that case is that we are actually pressurizing in the storage area, in the sphere itself, and we're kind of using that pressure to, hydrogen's light, and so you put some pressure in the system and kind of push it, as we say, push it up the hill. And so we started out with a lower pressure, but as we put additional pressure and got back closer to our fast fill rates, we started to see the leak. And so it was, I would say, in and around the 12 to, when we got up to 16%, we would take action. We saw that through the 3 different contingencies, but we were able to manage it. We would manage it with the pressure, get back within your leak rate in the cavity or get close to it. And so that's how we managed to get all the way to replenish. In terms of when we saw the spike in the leak, it was in terminal count. It was as we began to pressurize the tank, and whether that came from through the 8-inch or the 4-inch bleed, we really need to get into the plate and take a look, and we'll know more, in a few days when we get in there. So it'd be hard to say at this point. Again, the team's going through the data, so if you ask me tomorrow, I might have a better answer. But right now, I'd tell you that based on the timing, it looked like in real time that it was likely through the 8-inch. Could have been the 4 though. So we'll take a look at all that and see what was going on there. But it did go up, and it went up very quickly, and so we knew that we had something there we didn't understand. That's why the operator immediately gave a cutoff.
Wrap the side chat.
Okay, we'll go.
I'm trying to figure out where that question about the wet dress rehearsal was.
Go to Irene Klotz here, and then Will Robinson-Smith, and then we'll take a few more from the phone.
Hi, Irene Klotz with Aviation Week. I have a question first for Charlie or John. You ended up adjusting the timing for the wet dress because of the cold, but then did the wet dress in the really cold. Can you just explain a little bit about what you were doing during those 2 days, and if there was any equipment or systems that were close to like qualification limits because of the cold? And
oh, come on back now. It's all right.
Guys. Yeah, thanks, Irene. Yeah, we did. SpaceX did a report as soon as it happened on a Starlink flight that they had an upper stage anomaly. They're working that with the FAA.
Sorry,
so I don't want to get in front of that. The FAA is
Okay,
the
that's
lead
the
investigative
Falcon
body. We do have our teams with commercial crew embedded in that investigation, and so in terms of how it affects our plans for Crew 12, et cetera, we're pressing towards our Crew 12 window. We're planning towards, just a week, a little bit more than a week from now to start that preparation. But again, that's going to be contingent on the return to flight rationale, which we're heavily partnered with both the FAA and SpaceX.
This is the part I want to hear.
All right, the 2 days that we delayed wet dress. So let me say a couple things that weren't part of your question, but I'm really proud of the team that worked so hard to get to wet dress early. Right, we looked at what we could do to get there early. Our team had the work done. We were prepared to do wet dress 2 days earlier than we actually did it. And so that actually ended up being a wonderful thing. Now, the weather wasn't so wonderful, right? We were in unprecedented cold here in the state of Florida. We were very deliberate about looking at the weather and determining if we were in a configuration to do the test. Originally would have been, our T0 would have been Saturday evening when we ended up doing our call to stations. If you recall, on Saturday evening, it was very cold and it was very windy, and we did look at the weather and look at our criteria. The main criteria there for a wet dress, which is different than launch. On launch day, you absolutely have requirements for temperature and winds and other things. For wet dress, we did look at our temperatures because we needed to determine if we were within our certification limits for the ground hardware as well as for the flight hardware, and we looked at winds, and winds was really the more concerning item. There was 37.5 knots was what we were looking at as our constraint. And that was the primary driver for why we moved the wet dress originally from Saturday to Monday. And that was a great call because those of you who were here in the state of Florida during that time, you know that we had 50-plus knot winds on Saturday night. And so that would not have been a good configuration for us to be tanked in. It certainly would not have been a good configuration for us to send our closeout crew to the pad. And so that was part of the consideration for moving it. In terms of how did things go, we certainly saw.
I got it. No, dang it.
I mean, it increased. We got up to, probably 12-14%. And then when we tripped, all right, the 2 days that we delayed wet dress. So let me say a couple things that weren't part of your question, but would have been, our T0 would have been Saturday evening when we ended up doing our call to stations. If you recall, on Saturday evening, it was very cold and it was very windy, and we did look at the weather and look at our criteria. The main criteria there for a wet dress, which is different than launch. On launch day, you absolutely have requirements for temperature and winds and other things. For wet dress, we did look at our temperatures because we needed to determine if we were within our certification limits for the ground hardware as well as for the flight hardware, and we looked at winds, and winds was really the more concerning item. There was 37.5 knots was what we were looking at as our constraint.
Why would they be
and that
different?
was the primary driver for why we moved the wet dress originally from Saturday to Monday. And that was a great call because those of you who were here in the state of Florida during that time, you know that we had 50-plus knot winds on Saturday night. And so that would not have been a good configuration for us to be tanked in. It certainly would not have been a good configuration for us to send our closeout crew to the pad. And so that was part of the consideration for moving it. In terms of how did things go, we certainly saw in some of our, I'll say, pneumatic equipment, right, that is sensitive to temperatures. We saw some fluctuation in some of our regs, but we have as part of the configuration and part of the control on those, they have some automatic or E-reg control that accounts for changes in temperature and pressure. And so we were able to manage all of that. There wasn't anything significant that I would say came out of yesterday other than, activation of some heaters and those types of things. In terms of protecting the vehicle, we had purge going to the aft skirts during the, during the cold weather period. Sorry. Sorry about that. We had purge go into the vehicle. We had heaters configured. So in terms of taking care of the hardware at the pad, we had all the right things in place.
Okay,
over
so
here to-
yeah, all right. I did not understand that question exactly right, but yeah. So they when it was cold, they didn't go, and then they went when the temperatures were better. But it would have been too windy to launch, but they're not launching, so it's okay. Yeah, that makes a lot more sense. All right, so did I hear that right? I'm pretty sure I heard that right. They chose wind over temperature. Okay, that makes me feel a little bit better. So that goes back to what I originally was thinking. Like, yeah, how does this happen again? And guys, it's defaulting back to lack of hardware. That's really what this is coming down to. Lack of hardware. There's not enough hardware to do the type of testing that you're going to need to validate all these systems. And because of this, they can only really fully test the vehicle when it's fully assembled. It's not like they have another one ready to go. Close, but not ready to go. She was talking about Saturday, not Monday. Yeah.
Discovery.
Hey, Demon Hat, 92-month resub. Thank you. Interesting. They do, Fluffy, which they actually do. Yeah, I can show you exactly where it is. I see, that's what I don't understand. Shut off Google Earth Community. That's their umbilical testing area. Now, if I'm looking at this right, it very much does not seem like they flow fuel through this umbilical testing area, but yeah. But yeah, this is where they do all the umbilical testing. Like I said, it's very weird because I still just don't understand how. I mean, okay. So guys, now that I'm thinking about this a little bit more, now that I've, we kind of watch it through again, and I'm understanding what I'm looking at here, and it very much seems like they did do a lot of work. The umbilical leaking, either way, that's not okay. That very much shows that, clearly it's not test as you fly, right? How can you test the connections without identical fuel types? Don't know. Yeah, I don't. I just checked. NASA doesn't use spring-energized seals. Ariane does. Yeah. Also, wet dress rehearsal criteria being different than flying criteria sounds kind of stupid. Yeah. Yeah. Can I hear that thing about the wet dress one more time? I just want to listen to it again, just to make sure I got my mind wrapped around this.
To replenish. In terms of I would start high and then low skin.
In that space, possibly trip the limit during terminal count?
So let me start with when we saw the leaks. Let me start there. So, what we have learned during the Artemis tanking campaign is that this interface is sensitive to flow rates and pressures. We learned that during Artemis 1, and we saw the same thing. Yesterday. It was when we went to fast fill. We were in slow fill. We were within our limits and within our bands. It was when we transitioned to fast fill that we began to see the limits creeping up, or the concentrations within the cavity creeping up. And we did, was it a steady rate? I mean, it increased. We got up to, probably 12, 14%. And then when we got close to the 16%, that's when we did stop flow and revert, and decided to invoke our procedure for letting that interface warm up and then retrying it again. During Artemis 1, we found that sometimes I was very successful. I mean, that's a pressure-assisted seal, so sometimes letting it warm up and then putting some more pressure across it, you'll see the seal improve. And so that was the goal yesterday. When we tried it the second time, the performance was pretty similar. We have the ability, and what we do in that case is that we are actually pressurizing in the storage area, in the sphere itself, and we're kind of using that pressure to, hydrogen's light, and so you put some pressure in the system and kind of push it, as we say, push it up the hill. And so we started out with a lower pressure, but as we put additional pressure and got back closer to our fast fill rates, we started to see the leak. And so it was, I would say, in and around the 12 to, when we got up to 16%, we would take action. We saw that through the 3 different contingencies, but we were able to manage it. We would manage it with the pressure, get back within your leak rate in the cavity or get close to it. And so that's how we managed to get all the way to replenish.
So, interesting point of note. Now, it's probably better to go and watch this stuff again. Interesting point of note that they back purged the tank for additional pressure with hydrogen in the secondary sphere. So, Launch Complex 39B used to have a liquid oxygen sphere and a liquid hydrogen sphere. They would go to the external tank on the space shuttle. Pretty straightforward stuff. Now there's 2. There's 2 hydrogen tanks. The reason why they increased the fuel capacity of the pad is for scrubs. In case something goes wrong, you need a scrub. You don't need to get the trucks out there. You just use the second tank. But they're also using residual pressure from that tank on the umbilical, an untested thing. How are you going to test that? You ain't going to test that until you get to the pad. How are you going to test for that without a launch vehicle to tank? So that could have tripped the leak using that additional pressure. The reason why I know this is different is because the second hydrogen sphere was not online for Artemis 1 in 2022. They weren't using it. It was a new issue, so the Artemis 1 fixes work. Yeah, so what caused this new issue, Yuri? 1739. through 1739. I'm reading. Give me a second. 40,000 ppm GH2 concentration has been established to protect potential flammability concerns of a vented GH2 GHE gas mixture. They're purging with helium, not nitrogen. No. Deadbringer. Helium. They're worried about a GH2 GHE mix. Is SLS purged with nitrogen and not helium? Okay. Okay. Interesting. There's not a lot of public documents on these like SLS, yeah. It should be helium. Yeah, N2 would just freeze at LH2 temperatures. Yeah, Black Eagle, that's my guess. They're probably using helium as well.
In terms of when we saw the spike in the leak, it was in terminal count. It was as we began to pressurize the tank, and whether that came from through the 8-inch or the 4-inch bleed, we really need to get into the plate and take a look, and we'll know more, in a few days when we get in there. So it'd be hard to say at this point. Again, the team's going through the data, so if you ask me tomorrow, I might have a better answer. But right now, I'd tell you that based on the timing, it looked like in real time that it was likely through the 8-inch. Could have been the 4 though. So we'll take a look at all that and see what was going on there. But it did go up, and it went up very quickly, and so we knew that we had something there we didn't understand. That's why the operator immediately gave a cutoff, and we got into safing.
Now that I listened to this again, dudes, and this is on me for talking myself through it on stream, it doesn't seem like there's as much weird behavior here as kind of what was overtly given off the first time we watched this. However, yeah, it shouldn't be leaking. It still shouldn't be doing that. A few days, once the ship is saved, that thing should be torn apart in hours. Where's the urgency? Yeah, Fluffy, if it was me, I would have sent people out there this morning. Yeah, put up a couple of tents around the umbilical and start taking that thing apart. Doesn't change the fact that they had 3 years to fix this. Yeah. So guys, it's a pressure-driven seal. So it only really it seals fully with back pressure, which I'm not 100% sure that that's the right way to do that, but what do I know? The thing about hydrogen is that it's really tough to get that seal to seat correctly, no matter what your manner of actuation for sealing is. Hydrogen, you're talking about minus 400 Fahrenheit, minus 290 Celsius. Everything contracts. Everything shrinks up. Everything contracts. It's tough to get a seal to contract and then seat correctly. That it is tough. That is hard. We know that that's difficult. However, that's not I can't solve this problem in 3 years level of difficult, to be 100% honest with you. Check Space Coast Live. Yeah, I see it. There's a fairing up there. If it's a pressure-driven seal, the seal is affected by pressure. Not enough pressure means it doesn't seal. Too much pressure would then also mean it doesn't seal. Yeah, first, that's why I think it's very interesting that they opted for that extra pressure with the second LH2 tank. So that means they changed the fueling procedure as well, which I don't know why you'd do that, but yeah. Yeah, I'm not sure why would you use additional pressure? Maybe maybe it's because they have that additional pressure on tap so they can find where the nominal area is. But once again, why wasn't this tested? Why that's what I mean. You'd think that they would do some testing at some point. Do they not have the facilities to do this? Yeah, Fluffy, that really comes down to it at the end of the day. At the end of the day, the physics doesn't lie. You didn't do your homework. Like, you can't screw this up, dude. Like, Physics don't lie. If you get contract, like if you're an engineering firm, you get contracted to build a bridge. You build a bridge and the bridge falls over. You didn't build it good enough. Like, there's no getting around that. Last, please. It's your view coming from an industry military. Yeah, I know, John. You said don't go fast. So that very much seems like what they're doing. But yeah. I don't. It seems like now that I'm really looking at this more, it seems like this thing is like 95% good to go. But 95% good to go isn't enough to fly. That's the problem. It seems like they got a vast majority of stuff figured out, and the stuff that they didn't have figured out, i.e. what caused this leak, is some type of thing that's different than Artemis 1. Who knows? The fixes that could have fixed the original leaking problem on I believe it was on the 8-inch line, they could have worked. They could have worked just fine. And maybe that made another problem. But that's the kind of stuff should have been picked up in testing. At the end of the day, I just don't think to my knowledge, I don't think there is any way for them to do an actual flow rate test of this dang thing until they get a vehicle on the pad. And you know what, dudes? I don't like it. I don't like that. I think that's dumb. Dude, if the 1960s NASA was having an issue with this, right? And they didn't have another Saturn V available to them, dude, they'd probably go get 2 freaking tanker trucks, and attach the tanker truck to the damn umbilical and shoot hydrogen through the umbilical to figure out how they could get that seal the freaking seat correctly. Like, what? It very much seems like that wasn't done. Like, I don't understand. Yeah, exactly, Fluffy. That's exactly what I'm getting at. Yeah, it's fine. That's against OSHA's today. The government, it's the government, Scots. You don't need to worry about that. Who's to say that the wet dress rehearsal passed and on launch day something goes wrong? You can test all you want. Mumanji, same exact problem as Artemis 1 happened. They had leak rates during LH2 fast fill and pressurization. And then when they went to pressurize the tank for flight, the umbilical started leaking past an unacceptable leak rate, it's very interesting that happened during tank pressurization. Yeah. Interesting. Yeah, I know one, man. Yeah, fellas, I think this really is coming back. This is what I mean about Eric Berger's question. I think Eric Berger's question was fine. This is really coming back to you don't really have enough hardware to do the type of testing that you want to do here. Yeah, I don't know. I feel a little bit better than I did before, but also, like, I'm not. That press conference didn't really inspire too much confidence. I'm sorry, I'll shut up. Just for me, if I acted this way in a projects group, I'd lose my job. That's right, Fluffy. Yeah, dude. Maybe this is a serious question after all. Why are they filling quickly? LH2, you need to tank the hydrogen relatively quickly, O-Force, but yeah, yeah. You need to do it fast because hydrogen will boil off. You need to get the tank down to temperature as quickly as possible. Yeah, Vaquero. The problem is complicated. That's why we gave you 3 years and billions of dollars to figure it out. There's definitely incompetence going on here. ARJ, like, I agree, man. I don't want to be that guy, and I really, really don't like second guessing NASA, but the testing don't lie, dude. Your results don't lie. Like, physics doesn't lie. You had this problem with the umbilical. You were worried about leak rates with the umbilical, right? Maybe the mitigations that they did with that fixed it, but it didn't fix it now. And this is what matters. Like, I always try to put myself in a position that I don't know more than NASA, but also at the same time, dude, like, there's no getting around it. That thing should have worked and it didn't. And that means someone's not doing their job. Straight up. It's not. You can't pressurize liquid hydrogen at 20 bar, ride tech. It's lower than that. Hydrogen, yeah. If you try to if you overpress that tank, it's just going to leak. Like, I don't want to be that guy, and I don't want to sit here and pretend like I know more. But once again, physics don't lie. Could I do better? Probably not. Mine probably would have exploded. Like, NASA made EJ agree with Eric Berger. Mayor, that's the thing. Eric Berger is the one that doesn't like SLS. I have always advocated for more hardware rich with the SLS program. I've been saying that for a decade. You need to make more SLSs. You need to block buy this thing, because this is the kind of stuff you're going to run into if you launch once every 3 years. You know, there's no, I'm not going to say urgency, right? But that's the truth. There is no urgency. But then again, you don't want to be too urgent either. Like, they're not. But then again, they're not trying to launch an SLS like every week. Like 1 to 2 times a year is the right amount of urgency, because at least at the end of Artemis 1, you can be like, okay, we have 6 months. We got to get this umbilical ready to go. Are you telling me that SLS hips don't lie? Yeah, baby. Those SRBs don't lie. And she thick down south, man. I'm just saying. Damn, she thick. You know, Falcon 9's grounded temporarily, Ride Tech. They had a problem with the second stage deorbit the other day. Did they say that, Vaquero? There's not enough flight hardware to test properly. Did they say that in the press conference at all? Or was that just something that we've come to the conclusion here? Joke question. Would it be possible to convert RS-25s in the core stage to methane? I wouldn't. Okay, just us. All right, man. What I can't get over is the Apollo program cost $250 billion. Artemis is about $100 billion. One started from the ultimate starting point. The other, yeah, Astro, well, I think that deadlines are the problem there. Because, yeah, SLS, dude, it kills me to say this, but SLS has cost just as much as Constellation. Constellation was projected to cost $100 billion through life cycle into the 2020s. SLS, the entire Artemis program's at like $93 billion. And what do they have to say for it? One launch? This is what I mean when I say getting rid of Constellation was a very, very bad idea. But what do I know, dude? Well, I hope they can figure this stuff out, dudes. I hope they can. That press conference was not, didn't inspire much confidence, to be honest. We'll see what happens. We'll see where it takes us. What is the Constellation program? Is that a stargazing app? Yep. That's fair, Fluffy. Yeah, you can do that. I'll ignore you, but you can do it. At least it's just a wet dress rehearsal, not the launch. Good luck to them figuring this out. Yeah. Phil, possibly dumb question. Since the leak occurs in a purged cavity and then vented to atmosphere, why don't they route it out of the flare stack? Or maybe they already do. The purging line, the bleed and the purging lines are the ones that go to the flare stack, Phil. I just don't understand how it doesn't leak anywhere else but right there. Like, what's so different about the umbilical? Like, I mean, well, I know that it's the umbilical, but yeah, it's an interface, but yeah. No other place leaks? Nothing? Okay. Do you know, how long do you think SLS will be used? I have no idea. Hard to say at this point. I wanted to launch more, so we'll see, but... All right, well, we covered this pretty good. I really would want to watch more of that press conference just to really really make sure that I understand what they were saying, but... It ain't no problem. How's the head feeling? I know you were kind of out of it last night. I'm okay. I didn't really get much sleep last night again because the SLS. Because SLS was going, but whatever happened to Starliner? I think Boeing's asking the same question. Ride-Tech, they're aiming for 2 flights this year per Boeing's quarterly report. They're aiming for an uncrewed flight and then a crewed flight to the space station. The real question is, will SLS survive the next economic crisis? Yes, of course it will. Also, in the past, there's been a few instances of an engine being modified to run on a different fuel. Yeah. Black Eagle, you're right. The LR-87 can run off different fuels, but also the Space Shuttle engine is not an LR-87. You cannot retool SLS for methane. It's not a good idea. Remember, I mean, guys, I guess the important thing to understand from this whole press conference is that they're close. You're close to getting it right. At the end of the day, guys, what do I always say? Flight data is king. Nothing is going to substitute putting that thing on the pad and seeing what happens. The more you do that, the more data you get on the vehicle, the more you understand how good or bad your analysis is. There's no getting around it. So Flight 12, Blue Glen 3, or Artemis 2 first? I don't know, Fluffy. I'd say New Glen. Do I hear radio in the background? Nope. I don't have any background on right now, but then again, my headset's off too. I got this headset up and working today too, dudes, which is good. You might be hearing the television in the other room, in the shop. I should probably go turn that down. All right, dudes. Let's go play Summer Car. I think we've done a pretty good space news for the day. Yeah, let's get that car up and running. Or, well, not up and running. Let's go do some tests. I'm going to jog the VOD. I'll be right back. Flip over to MSC or My Winter Car Now. And, yeah, we'll start driving that car around.
Go at throttle up.
Thank you very much for watching. Sorry, I didn't mean to doom and gloom this too hard, but yeah, I don't. Yeah, I guess to conclude it, the physics don't lie. Somebody didn't do their homework, and that's not okay. It's not okay because now we've delayed our lunar ambitions because someone's not doing their job. Now, what it is, I don't know. I can't speak to the details. If I had to guess, it probably might have something to do with John Honeycutt because he did not look happy. So we'll see. But anyway, hopefully we can get another wet dress rehearsal. And then when we do get another wet dress rehearsal, I will be here covering it to watch it leak again. Let's go play winner card. Thank you very much for watching. I'm Jog the VOD. We'll be right back. YouTube, stand by for loss of signal as expected.